Alrighties, hello there. Welcome to your pre-lesson video today on bar graphs, line graphs, circle graphs, histograms, and Venn diagrams. Let's get right into it. So, with your graphs and stuff, what you would essentially need to do on the ACT and SAT is to be able to read them, right? And we'll be doing most of the reading on like learning how to read the graphs during your deep dive session. But for right now, your pre-lesson video, we're just gonna go over what exactly are all these kind of graphs and how to form them, because if you are able to form them, then you should be able to do the reverse. You should be able to deconstruct and interpret information from them, which is what we would need to be able to do during your deep dive session, because during the tests themselves, you need to learn how to pull out information from the graphs, all right? So the first graph that we're going to look at today is the bar graph. So essentially a bar graph is, as you can see, is a graphical display of data using bars of different heights. See how these are all different heights? All right, and it's a specific way of representing data using rectangular bars where the length of each bar is proportional to the value that they represent, right? Now the bars, as you can see, they can be shown either vertically or horizontally. So this is a vertical bar graph and this is a horizontal bar graph. All right, so you can have the bar graphs either way. It doesn't really matter which way it is as long as you are able to put the information in correctly. All right, now some properties of bar graph. As you can see, all rectangular bars should have equal width and should have equal space between them. So as you can see, all these bars here, they are about equal width. They're not going to be like one is thicker than the other. They all should be about the same width. Plus, as you can see, the space between each category is about the same also. And there's a reason for that. All right, and then the height of the rectangular bar is equivalent to the data that they represent. So as you can see for like this one, in its axis, the height of each bar, as you can see, it goes by intervals of 5s. So the height of each bar is equivalent to the data that they represent. So like for grapes, there's 5 people who like them. For blueberry, as you can see, there's 40 people who like them. And so that's what it means by the height of the rectangular bars is equivalent to the data that they represent. All right, and then the rectangular bars must be on a common base. So as you can see, they all start on this end here. So this is the common base. You can't have one bar here and then another bar starting like halfway floating through here. No, they have to start on a common base. All right. Now, some uses of bar graphs is that they are used to compare data sets that are independent of each other. And what they mean by independent is that the x and y values, each x values, they don't influence each other. All right, and with bar graphs, it helps in studying patterns over long periods of times. All right, so again, there are a few types of bar graphs. We've already seen the vertical and horizontal bar graph on top, and then there's also a stacked bar graph, which would look like this, and a grouped bar graph. Now, for a stacked bar graph, as you can see, we have different boxes stacked on top of each other, and they're all color coded, right? So this would be stacked. So like this might be for girls, this might be for boys, something else. It really depends on what each color represents. All right, and so this is how a stacked bar graph would look like, and this is a group bar graph. So essentially, a stacked bar graph could also look like this. You would just take, instead of putting them on top of each other, you would just put them side by side like this. All right, not to worry about. The more common one that comes on tests are these kinds. All right, now how to draw a bar graph. All right, so these are some of the tips, the steps. So first, you want to give the title of the bar graph, like most bought fruit or favorite color, depending normally on what the x-axis is, right? And then you want to draw the x-axis and y-axis on a plane, right? Then you want to label the x-axis based on the independent variable and the y-axis based on the dependent variable. And then you want to label the space where the bars would be on the x-axis based on the categories that are in the independent variable, and leave an equal space between each bar on the x-axis. And then you want to give the scale of the graph, or at least determine it. You don't actually need to put it out there. You just need to determine yourself what the scale is, right? So that way the markings between each intervals are the same. So give the scale of the graph, which shows the way in which numbers are used in the data. It is a system of marks at fixed intervals, as you can see, which helps in measuring objects. For example, the scale between can be written as like 1 unit equals 5 children, like in this case. And then start making the rectangular bars with equal gaps for each category and give height to their respective numbers. And then the bar graph is ready for and interpretation of information to answer the questions can now be done. Right? So that was probably a lot. We're gonna do an example of how to draw a bar graph now. So first things first, remember we want to write the title. So we know that the table is called favorite type of movie, so that's going to be our title. All right. So let's see, our title is going to be favorite type of movie. And then the next thing we want to do is draw our axis. So we have our y-axis, and this is going to be our x-axis. Okay. The next thing we want to do is label the axis based on our variable. So I know our x-axis is going to be type of movie, and then our y-axis, its name, if we can write aside, it's going to be number of people. Alright, so that's just labeling the axis. And now we want to label the space where the bars would be on the x-axis based on the categories. So the categories in this case are going to be like comedy, action, romance, drama, and sci-fi. So we're going to label that right now. So let's see, we have comedy here, and then action, then romance, drama, and sci-fi. Alright, now once we have labeled our x-axis, we are going to give a scale for our y-axis. So I have determined, I'm going to use for 1 unit, it's going to be 1 person. So I'm just going to estimate right now that they're going to be about equal spacing, right? So if you're doing this on paper, you obviously would want to use a ruler, measure it out, and all that. 6, 7, and 8. Okay, so they should be evenly spaced out. And now I want to start making my rectangular bar. So let's look. Comedy has 4 people, so I want it to at least be up until here. That's how thick my bar is going to be, roughly. Alright, now for action, there's going to be 5 people, so it's going to be from there. And obviously, if you're drawing this on paper, you'll be using a ruler and making sure that each of your bars are about the same thickness. Alright, now romance has 6 people, so you want to draw that like that. Make sure your lines are straight, so use a ruler, please. Alright, drama has 1 person, so it'll be really, really small, like just right there. And sci-fi 4. Alright, so we estimate, obviously use a ruler, should be around there, maybe a little bit less. Alright, so this is how your bar graph will look like, roughly. Obviously, it'll look a lot neater if you're using a ruler, but yes, this is how you make a bar graph. And then from here, now you can interpret information if you're not given a table. Alright, now on to the next thing, a histogram. Alright, so a histogram is a type of bar graph that shows the frequency of data in various intervals. Right? So for example, it's like the number of residents in a given neighborhood that are age 21 to 30, age 31 to 40, and so on, right? And so group numbers, so the groups, they are numbered into ranges, which we call class intervals. So like as you can see, this range, this class interval is going to be 21 and 30, and then the next one is like 31 to 40, and then the next one will be like 41 to 50, and so on. All right, so those are the class intervals. Now, same thing as usual, like your bar graph, the height of each bar shows how many fall into each range. And histograms are used to show results of continuous data such as weight, height, and how much time, and etc. The reason we're not using an actual like bar graph is because if you were to label for each age, for example, like it'll be too many bars, it'll be too cramped, it won't look good, which is why we would use a histogram because it's in intervals, right? It's all clumped into one range. All right. Now, as you can see, the difference between bar graph and histogram. So bar graphs have equal gaps, see these gaps, between each bar, whereas histograms has no gaps because they're intervals. They are paired and with each other. They're continuous to each other. All right. And then bar graphs are used to compare various variables and are used to plot categorical data, such as data of types of animals, types of colors, types of movies, something that can be separated into categories, whereas histograms are used to represent distributions of variables and plot quantitative data, such as the data of population changes every year, marks obtained, monthly salary. So like there's a range of the data that you can use, right? So as you can see, categories, number ranges, and there's no gaps. There's no gaps in histograms, but bar graphs do. All right. But the big thing really with histograms is that they have number ranges. Right. So types of histograms, the very common one that we all have are frequency histograms, as you can see, right? So because it shows the frequencies of the given data. And after that, it's based on the shape. So bell-shaped histogram, as you can see, if you go get into statistics in the future, it will form this kind of shape. So it looks like an upside down bell like this. That's why it's called a bell-shaped histogram. This is a bimodal histogram because there's two peaks, as you can see. This is a uniform histogram because it's pretty much, as you can see, flat at the top. This is a skewed right histogram because it has a tail at the end, so it will look like this. So it's based on the tail, that's why it's skewed right. And this is skewed left because it has a tail to the left. So you don't really need to remember what all these are called, but it's just really handy to know how they look like and what they're called, but not necessary. All right. Now, how to draw a histogram is pretty similar to a bar graph, just a little bit different, right? So again, you want to give their title and everything, and the data, you want to group everything into ranges first. All right. So as you can see, begin by marking the class intervals on the x-axis and frequencies on the y-axis. But if you're given data like this, obviously, like I said, you want to compile it into a table first. That way you can see like what your range is, how you want to label your class intervals on the x-axis, same thing with the y-axis and all that. So if given data like this, compile it into a table, which is what I did already. All right. And then make sure the scales on both axes are the same for each, and the class intervals are exclusive. All right, which means they don't overlap with each other. Like you don't want your class intervals to be like 60 and 65 and 63 and 68. See how that overlaps? You want it like separately. And after that, you're going to draw rectangles with bases for the class intervals and corresponding frequencies as its height, like your bar graph, right? And then it's done. Now let's look at this example. We have Uncle Bruno owns a garden with 30 black cherry trees. Each tree is of a different height. The height of the trees in inches or all of that. Okay? So then, now with all those numbers, you want to group it into a table, right? So I already done that, and it's grouped into this table. Now from here, I'm going to form my histogram. So my title is going to be height of cherry trees of black cherry trees. There we go. All right. Now I'm going to draw my axis. Actually, I'm going to draw a little bit more to the center. So here, and then this little ziggy lines to show that it doesn't. There are numbers between. As you can see, I'm going to start with 60 here, and so forth later. All right, and then I'm going to have my intervals. So I'm going to have 60 and then 65, 70, 75, 80, 85, and then 90. Okay, this is 0. So yeah, and then let's see, we have 1. So I've already determined my scale and everything. 4, 5, 6, 7, 8. I need more. Let's see. Ooh, I don't have enough space. I need 10 because the highest number that I have here is 10. Okay. So 10 there. 9 and... Alright, 10. Okay. We're just gonna move the title, all of this, to the side real quick. Just because in a second you'll see that it's gonna be, the bar is gonna reach there. So imagine our titles here. So title, right? So height of black cherry tree. We just don't have space. But normally you'll write it on top here, but we just don't have space right now. Okay, so now let's get to drawing your bars. So from 60 to 65, I have 3 people. So it should be about from here, here, and then 66 to 70 would be same thing, 3. So here. Again, use a ruler when you're drawing. Alright, and then from 71 to 75, we have about 8. So it would be around here. So see how I'm drawing it? It's like your bar graph, except that now they're based on intervals. Okay, and then from 81 to 85 is 5 people, so it should be around there. There we go. And then finally we have 1 person, so it'll be like this. And so this is how your histogram will look like. Obviously it'll look a lot neater if you're using a ruler, but this is generally how you draw a histogram. Alright? And luckily, like I said, on the test, you wouldn't need to draw it. You just need to be able to, 1, recognize what kind of graph it is, and 2, be able to interpret the information that they're asking for. Alright? Next thing that we have, it's a line graph. So a line graph is to show information that changes over time, and it can be plotted by using several points linked by straight lines, like the points on the coordinate grid. Alright, and then you can have more than one line to show multiple sets of data on the same graph, like the average height of boys versus girls at different ages. And the slope of the line helps in comparing the magnitude of change between any 2 consecutive points on the graph. So again, like between this point and this point, I know it's going to be like a negative magnitude because it's going to be a negative slope. And then from here to here, it's going to be a positive magnitude of change. Alright, so that kind of stuff. Now we have 2 types of line graphs, which is a simple line graph, which is just 1 line, and a multiple line graph where you have multiple lines in a graph. Alright, now we're just going to go straight ahead into building that graph. So again, I, as usual, want to create my title. So it's going to be, I'm going to write on the side here. Alright, so number of middle school students from 2008 to 2013. Alright, and I'm going to draw my axis. Again, I want to label it, so I'm going to label here number of students, and then the bottom is going to be year. Alright, again, you want equal spacing, so this is going to be 2008, and then 2009, 2010, 2011, 2012, and 2013. Again, label this also, so you want to divide it as usual. So this time I'm going to use 1 unit is 100 students. So 100, 200, 300, 400, 500, 600, 700, 800, 900. Oh, we're going to go past it. What do we actually need now? Okay, so from there. Alrighty, so now I'm going to use two colors because as you can see we have two middle schools, so I'm going to use different colors to differentiate them. So I'm going to use, normally you also have a legend, right, which tells you what color is what. So for pink, it's going to be my island middle school. So let's plot. At 2008, I have 700 students, so we'll be about here. And then for 2009, I have 600, so it should be about here. 2010, 700, so back up there again. 2011 is going to be 800, so it should be about right there. 2012 is going to be 900, so right on top there. And then 2013 is going to be 700, so right there. And then from here, I'm going to connect the dots in a straight line, right? So it's going to go boom, 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 right there. So that's how Island Middle School's trend is going to look like. Now let's do for Eden Middle School. All right, so Eden is 500, and then next year is 400, and the next year is 600, and then let's see, the following year is back to 500 again, and then 600, and then finally, oops, I just realized I plotted that wrongly for this one. All right. Let's actually just finish a middle Eden first. All right, and then this would be, oh, just coincidentally, we're going to use that dot. All right, and then we connect the dots. Make sure, obviously, it's a straight line, but I'm drawing freehand right now. All right, so the trend will look like that. And then now let's correct island. All right, so island, your last dot should be about here because it's 800. Okay, so now if we draw the lines, it'll go here, and then up, and then up, and then there. All right, and so your line graph, if you were to do it obviously by using rulers and everything, should look roughly like that. All right. Luckily, again, as usual, you don't need to draw it, you just need to learn how to interpret it. Now, for circle graphs, they're also known as a pie chart. And so it uses different size pie pieces to show parts of a data set and how it compares to the whole data set. All right. And now each pie piece represents a given percent of the entire circle. And obviously, because it's a percent, all pie pieces must add to 100%. All right. And the arc length of each slice, and consequently the area and central angle it forms in a pie chart, is proportional to the quantity it represents. And we're actually going to see in a second as we form the pie chart. And now what normally circle graphs or pie charts are used is to compare given data, right? So this is a pie chart. Now, pie chart formulas, which you do need to know. So to calculate a percentage of the given data, you want to take the frequency that you're given for that specific piece over the total frequency. So if we look like egg, right? Let's see, egg is 1, 2, 3, 4, and its total is going to be 4, 5, 6, 7, 8, 9, 10. So it's going to be 4 over 10. So once we get that, we're going to multiply that by 100 to get the percentage of egg in this case, right? And then we also would need the degrees in order to draw the pie chart because it is a circle, right? So to convert the data into degrees, we're going to give the given data or the frequency divided by the total frequency times 360 degrees. All right, so essentially this part is going to be the same as just what you're multiplying with. If you're multiplying it by 100%, you're going to go find a percentage. If you multiply it by 360, you're going to find the central angle of that pie slice. All right. Now, to construct a pie chart, if you don't have a table yet, do construct a data table so you know how much each percentage, or especially you definitely at least need the degrees, right? And make sure you add up all the values to get a total. Now, and then you want to use the above formulas to find the percentage and degrees for each pie sector. And once the degrees are calculated, you can draw a circle using the calculated measurements with the help of a protractor. right? And then you want to label each sector. They're just drawn accordingly. And then finally, your pie chart's ready. So let's look at this. So we're given this question. Construct a pie chart to visually display the favorite fruits of the students in the class based on the given data. So mango is 45, orange is 30 students, plum is 15, pineapple 30 students, and melons 30. All right. So we were given this, and then I've already compiled into a data table. So we know for each sector, each type is going to have this many people, and the total is going to be 150. All right, now I want to find degree and percentage by putting it into the formula. So for mango, it's 45 over 45 because that's a given, because that's a frequency, over the total frequency, which is 150 times 360, which is going to give me 108 degrees. Now for orange, it's going to be 72 degrees. Normally at this part, you would just have a calculator, so you would just put everything in a calculator to find out what these answers are, all right? So that's going to be 36, and 72, and 72 degrees. So we at least need the degrees in order to know how much of a sector is going to be in the pie chart. All right, now for the percentage, we'll put all of this that's in the formula into your calculator to get your percentage. All right, so we get 30%, then 20%, 10%, 20%, and then 20%. All right, beautiful. Now that we have all our data, we can draw a pie chart. All right, so first thing we want, as usual, label. Give it a title. So, favorite fruits. And then I'm going to draw my circle. Obviously, if you have a protractor, use it, but right now I'm going to try to draw as perfect of a circle as I can. All right, there we go. Now, my center should be about here. All right, now I'm going to draw my first sector. So I'm going to draw for mango first. So I'm going to take a protractor and I measure, okay, this is going to give me 30 degrees. I'm just estimating right now, by the way. So this is about like, sorry, not 30 degrees. That's about 108 degrees, right? And so now I'm going to label this as 30%. Sometimes they may not, and you might need to find it. But right now, I'm just writing the percentage since I did find it. And I know that this is 108 degrees. We don't actually need to write the degrees. But for right now, I'm just showing you that that's about 108 degrees. But yeah, you'll use a protractor to find out what that is. And then I know my next pie slice is going to be about 20%, which is 72 degrees. And this is going to be orange. So you definitely at least need to label like what each sector are. Like you definitely need to write, this is mango, this is orange, this is, let's see, this is pineapple. And then, let's see, this is melon. And then our last one is going to be plum, all right? And like I said, obviously it doesn't look 100% nice just because I'm drawing freehand. If you have a protractor, ruler, and all that, use it to draw your pie charts, as well as all your other graphs from before, all right? But essentially, this is how you would draw a pie chart, and then now you'll be able to interpret information from it, okay? On to our very last thing of the day, Venn diagrams. Really, really handy, especially because sometimes a lot of algebra questions might come out from Venn diagrams, so you do need to know how it looks like, all right? So a Venn diagram is used to visually represent the differences and similarities between the two concepts. So the part that overlaps is going to be the similarity, and the parts that don't overlap is going to be the differences. So as you can see, Venn diagram examples, the differences between, so this circle here is going to be multiples of 5 from 1 to 25, and then this here, this circle, is going to be even numbers from 1 to 25. And so what these two circles have in common is 10 and 20, because 10 and 20 is an even number and is a multiple of 5 from 1 to 25. All right. Same thing from here. This is just more than 2 circles. All right. So this is also something possibly that can come out in the SAT and ACT. And so during our deep dive lesson, we're actually going to see how we're going to form a Venn diagram based on word problems and use that to solve our question. All right. And that's it for today. If you have any questions, as usual, bring it to your deep dive lesson or send me an email. All right. Thanks for hanging in there and have a good rest of your day.